Let's see if this works. Yes, it works. Good day, folks. Hope everyone is doing well today. I'm just testing basically a new streaming interface here to see if this all works. And it seems it is, but I'm just not too sure yet if my audio is nice or not. So I'm gonna keep talking essentially for a few minutes, and I'm sure someone will tell me if the audio is bad or not. But from my side, it seems to be okay. I hope it's not distorted or anything. So I hope everyone is doing good today. It's pretty nice here at home for Northern Ontario today. It's about 70 degrees Fahrenheit, and it looks like it's going to be a nice day. It was clouding over, but looks like the sun wants to peak. But that doesn't really matter because I'm inside, right? So just making conversation here, and at the same time trying to tweak my audio as people are coming in here because I basically just go on random. I don't announce it, so I don't expect, that many people at the same time is able to catch my live sessions, but at least, you're able to watch them later on. They are saved. So today, basically, at some point, I like to talk about some switching and whatever else that comes to mind. And talk about my circuits that I'm trying to work on and some issues that I ran into that I haven't talked about yet that would be useful for others that want to experiment with this sort of circuit as well. So I will get into that momentarily, and at some point I like to just randomly experiment with some parts here I took out of the microwave. I wanted to do something with the fan. I don't have the fancy switching circuit yet, but I'd still like to experiment a little bit with it, just something to do. Sometimes, it's just messing around like that with no real expectation of what the outcome is that you actually end up, on the side finding some interesting way, something more efficient. So at some point, as you see, I got the layout set up. I hope it's a little bit better. So there's a second view there. See, right over here, hello. So if I'm working, you see, if I'm doing something, you can see it. And then I can go back here, and at the same time, you get more of the interaction here. So I hope everything is looking good on your end. Audio sounds good, awesome. That's what I was waiting for. Thank you for that. So I see there's some people that are coming in there, and my audio is good. So I can't help the background noise, the laptop always does that, the fan in the background, so that must be annoying. Sounds like some really harsh white noise, but filters could be used, but then it starts sounding like a hollow tube, right? So as I was saying, yeah, I'd like to talk about random switching circuits and the ones that I've been talking about, and maybe some discussions on Bedini stuff. And just see what I can do right here, right now, and around the I don't know, I guess I could call it my lab, the new room, the workstation. And yeah, so I hope everyone is doing well today. And I'm just going to wait a few more moments here, and then I'm going to basically get into what I wanted to talk about. So, yeah, let's see now. So I got everything, looks good here. So, yeah, awesome. So, basically, I've been cleaning up, as everyone can see, and setting up a new room here for my various experimentations and workshop, I guess, if you want to call it that, working area. Yeah, that's more like it. So now I'm pretty well organized, but the point is, it's trying to remember where everything is now to work on experiments. And taking, when I'm all organized like this, I keep saying this, but it's becoming a bit of a new learning curve just to figure out where everything is. So we're getting there, though. We're getting there. So again, hello everyone, and today is basically a normal weekday, so people might be out and about and at work or whatever. But that's okay because at some point I'm going to save this video for later so people can watch it if they don't see it through the live stream. So basically, as some people have been noticing, if they have been following me, I came up with this self-recovering Bedini circuit a while back. And it's a very interesting concept, you see. It's taking the Bedini, but one more level. And it just seemed to make sense that if you switch with a MOSFET at the same time, the negative and the positive, with not one diode, but two diodes on each side of the coil strategically placed here, you're able to literally isolate the inductive kickback from the MOSFET switching and force it back into the input bus. So a direct way of recycling the energy without having to worry of converting it into capacitors and transducing it with transformers and isolations or anything like this. This circuit is basically an all-in-one. Now it's a little bit unique because usually when we talk about MOSFET switching, we're usually using a dual MOSFET setup, which in one time one is on and the other time one is off, which gives you that square wave. But this is not the same kind of switching. What you want to do is we want to make sure that both of these MOSFETs are switching on and off at the same time. So they're the same switch controls both MOSFETs here essentially. Now the issue with that is it's essentially the MOSFETs that take care of the isolation during both of them being synchronized and off at the same time. Now I've started doing a little bit of experiments with this and I ran into some issues, so that's why I'm a little bit on hold for actually releasing the circuits for people here, because I got to find some high quality MOSFETs that respond as sharply as they can, because you really want them to be able to handle this sort of thing. And as well, the symmetry really matters, and I don't know why no one talks about this, and it might be relevant to other Bedini type circuits, and I will get into that. And what I've noticed is when I first built a prototype with some basically junk MOSFETs I had around the house here and I tested the circuit, I immediately ran into some issues which I knew that at some point other people would probably run into. You see, like here's the pulse width modulator that controls both MOSFET and each gate. So the output controls the gate of both. But the problem with this is the contact points and the symmetry and how you build the MOSFETs around the circuit board need to be perfectly symmetrical. Let me explain. What happens is originally I had one lead wire running a lot longer, let's say 10 inches on this one here, and one coming out here and crossing out and being only 2 inches. So there was a major symmetry-wise broken symmetry between the two MOSFETs, not through the frequency or the switch, but the actual electrical conductor. So the timing essentially of the electrical impulse needs to also be symmetrical between the two MOSFETs for this to work. So the best way of doing that is to actually make sure that your two contact point leads are the exact same length. Then this way here you know that electrically it will reach the signal of both MOSFETs at the same time. Now I haven't talked about this before, but I think it's a very important part of it if anyone wants to experiment with this. And this also brings me into the regular Bedini multiple coil stuff. You know, where you have people building multiple coil Bedini systems, okay? Where you have your power source feeding every coil essentially. What I'm getting at is he doesn't tell you this, but let's say like the last coil might need 10 inches of wire while the coil closest to you might only need 3. What I would do is I would make all of the leads 10 inches, so every coil around the Bedini system is symmetrical to the pulse, essentially. If that makes any sense. It depends on the design. Some of them all have their own transistors, while other ones, like Bedini on the energy from the vacuum, was showing a similar thing like this, or he would just make multiple taps, you see. So it does depend on the circuit design, but in a lot of these switching circuits, people never mention that if you're going to, especially with multiple coil systems, it's not just resonance, but it's the actual electrical timing to all of these coils that you're triggering at the same time. So if your leads are different lengths, that means the electrical timing, even if it's in a fraction of the NS range, you're going to have some issues there with intermittent shortings. Even if it's very sharp, that might be enough what Bedini was describing as blowing transistors and making holes through the wall. That's what you don't want, right? So just thought I'd share that observation with you folks, that electrical timing just on the geometry matters of the circuit board from your triggers. Because if you're expecting to trigger some multiple coils all at the same time, especially with one switch, you have to make sure your electrical timing is in sync with all the devices. So if you have sloppy leads on one side and longer leads and shorter leads, the timing is going to be all different between every device. If that's what you want, that's fine. But if it's not, that's going to be a big problem, obviously. Yeah, the distance of the switch changes the symmetric. So if you have dual MOSFETs and they need to switch each side of the coil at exactly the same time, each gate wire from the trigger source needs to be the same length, or else you're going to have an electrical discrepancy between the two, and that might be just enough to cause an event that you don't want in between, like an intermittent short. So, yeah, that's essentially what I wanted to get into. And this is what I'm working on. So I don't have all the parts yet because I want to get some good MOSFETs. And I realized that the symmetry of the actual switch really matters for this kind of thing. So I'm going to have to make sure that even the PCB that's ready to be printed, that the actual symmetry of each component is one side is the same as the other side of the coil, essentially, distance-wise. So maybe some hints at people who experiment with the Don Smith stuff, where the actual the cut of your conductors really matter lengthwise. It's sometimes a little bit more than just randomly hooking everything up together, right? Especially when you get into switching. The system has to balance itself out. So, yeah, like I said, I'm just taking a pause once in a while to read what the users is interacting here. And this isn't my form because I corrected it, by the way. It's really doofy of me. I had the colors wrong here, black, and so I just flipped it and saved the image and uploaded it to my form. I mentioned it right on YouTube, but you always have some trolls which will say, look at that, it's all wrong. No, it's not. I just used the wrong color. The circuit is fine, but it's fixed anyways. But just to show you, people will pick on absolutely anything. Obvious formatting errors from cut and paste into one program to another. There's one instance where I had the ohm signs come up 2 times, instead of 1. It's all wrong. Yeah, well, most people would understand that was just a formatting issue, but, thanks for your interaction anyways, right? So again, for those who are just here, I hope everyone is doing well today, and I would just wanted to experiment a little bit here with this motor just to, it looks interesting, it seems easy to get to, so I wanted to see basically if I could drive it pretty good with reactive power. Pretty well already know the answer to it, but just see how well it would run, maybe. So maybe try that and see how things go and interact at the same time. So as you see now, you can see what I want to do. So here's my inverter because I don't like screwing around with the mains. So I've got my big battery down here. Oof. Oh. I'm going to put that and remove the microwave out of the way. So I'm doing microwave experiments as well. Move the microwave out of the way. Put the battery there. Plug in our inverter. Here. Positive here. It always goes click as it charges the capacitors in here. Seems fine. Yep. All right, so let's connect this. And boys and girls, don't do this at home. So here is my. So what I'm going to do, make sure that's off. Yes, I'll find out pretty quick anyways if it would be on. Got 1x capacitor here, but what I'd like to do is I'd like to let's just see if it will run straight through the capacitor. This little capacitor won't give it a lot of current. But it does a power correction. It's random, but whatever it does, if it's good, it could make the transfer of energy more efficient between the inverter and the motor here, which is this. The two probes are right here. I'm just going to check out if people are saying anything here. I'm good. All right. Because I can't see the user interaction while I'm facing this way, so I'm not ignoring you all. It's just I don't have a moderator running the live stream for me, so. All right, so I got this one here. This is an X capacitor, by the way. They're specifically rated to be used for reactive projects. And this is 250 volts AC, which means it should do okay. But it might not be enough capacitance to run the fan, I don't know. I'm just doing stuff because I feel like it, I guess. This is a something else, high voltage module. This is a test lamp. If it lights up on its own, please let me know. And this one here goes on one side. And the other side here goes to the motor. If I want to, I could tune it and everything with the Variac. This here like that. And then we turn it on and hopefully it wouldn't go boom, right? As if it goes boom. Oh my goodness. Let's see what people are saying here. So far so good. So I don't know about random capacitors, but we'll see if that fan goes on. No curves, not enough. Not enough at all. That's what I figured. So we'll try other values. Unless the fan is toast, maybe I can see if the fan at least works. So we'll try the fan directly. Fan works fine. So we need to find, I had a bunch of capacitors. If I really want to get serious, take this out here. Let's try something else. Let's try something else. You see, I've got bigger values here, but they are polarized. So the trick to that is to use two polarized capacitors and take either the plus or the negatives, put them together, and then on each side here you've got your neutral polarity, so it doesn't really matter. But the downside is whatever capacitance this is, so in this case 47 UF, it drops in half because you're using two capacitors. But it's still a quick fix if they've got the voltage rating, right? So these ones do 350 volts. So let's see if that'll do it. Turn it on. Holy moly, it's more efficient now. So that's what I mean with this is doing a power correction. Because not only is it reactive, but it's actually running much stronger with the two capacitors than just direct. So in other words, we've tuned our input to our load. So I knew that was going to work. It was just a matter of finding. But I just wanted to show you the bigger picture that you could use two polarized capacitors and turn them into one non-polarized AC capacitor and use that to run your reactive. And that really had resonance. That really gave it a, oof, the whole thing wanted to fly away almost there for a moment. But those are the type of surprises sometimes when you just experiment, right? You have an idea of what to do, and yeah, the teleportation stuff, yeah, actually long ago, before I even was on YouTube, talked a little bit about that. I had a lab somewhere in an attic in Timmins, Ontario. Started freaking out the neighbors because, you know, the Christmas lights in the middle of summer at night, like at 9 p.m. when it got dark, for like a mile and a half would all lit up on everyone's house and they all be disconnected, right? So it triggered, you know, Timmins police was getting curious, and then for a while, without getting into the details, they thought I was some sort of a spy, and it got really, really weird. I had to get like a paralegal involved and then legal aid and threatened to go after the Timmins police, and then they wanted to arrest me, and it was a big story. And one long story short, I lost all the stuff there because the owner of the building sided with the police, unfortunately, and didn't let me in to pick up my stuff, which was a friend at the time, which had an inheritance, which wasn't my stuff, which made it worse. He was just letting me borrow it. You know, there was like thousands and thousands of dollars of, stuff that still had the NASA stickers on it. Vector analyzers, you name it, and curve tracers, and even the calibration dates, which was still not bad, dating back to like 2012 or so. But unfortunately, he locked me out after the event and wouldn't let me get the stuff. And Timmins police said, well, it's a civil matter, you got to go to civil court. And having basically very little income, I couldn't proceed with basically taking him to court for small claims, which made it really bad because it wasn't even my stuff. It was something I was borrowing, and it was from a fellow international in the United States that was basically supporting my research through that method. And he wasn't very happy either. So it was very anyways, yeah, it was a bad thing. And if you're going to experiment with that sort of thing and big coils and stuff, do it in isolation, a camp in the bush, a big lot out in the country. Don't do it in a city. You're just looking for trouble. And that's what happened. So I basically stayed quiet for 2 years about in Timmins. Then I came back on YouTube with the energy stuff in focus and slowly starting to rebuild that way. And eventually, after about a year, moved out of Timmins and came back to Cochrane, Ontario, which basically a different municipality, different. It's like day and night. It's like a whole new world. People basically leave me alone here. I can do what I want. I could walk down the street with a radio and test a field strang. No one's going to stop me and ask me, They're worried of what I'm doing for their kids that live around. It was just really weird in Timmins. People were like, I don't know if it was the COVID or what, but everyone was like so on edge and scrambled in the mind. It was a non-pleasant experience. So take it as that, and perhaps advice if any one of you want to proceed in the John Hutchinson type of experiments. Stay low key is key, unfortunately. And it's my nature, right? I like to tell the neighbors what I was up to, what I was doing, what I was discovering, what I was aiming for. I think it's fascinating. But some people get very scared, especially those who are superstitious and that sort of thing, who believe in the demon forces and the occults and that sort of thing, get very fringy over this kind of stuff. So yeah. So that's the answer to that. Haven't done any of that teleportation stuff for years now. It's going to be close to 10, actually. All right, hi everyone. Again, just reading the comments. Yeah, it was all interesting stuff, and I really believe I was finding interesting things, but it was more intuition based back then. There was no Maxwell extended equations and my understandings of it and all of that I found out today. It was just basically trying to do the stuff Tesla was doing and just going brute force with that. And what happens if you put electrostatic, what happens if you put x-ray, what happens if you put on and on it goes, right? Eventually end up finding something if you keep at it, but it's hardly the scientific method, but it could be a hobby method, so nothing wrong with that, but far from the actual. Now is much better with the help of computers and programming and Python and AI and all of that. It's just, it helps us put all the pieces together, Very happy about that. So yes, I'm very happy that I was able to talk about the self-recovering Bedini circuit some more, and that I was able to cover just like that on the spot how you could use polarized capacitors on AC. If you hook two of them together, they become non-polarized, like the plus and the minus and minus of either one. So then you end up with one capacitor, but you got to divide your capacitance in half because you've got two. So that's the trade-off that comes with that, but pretty good. And as you see, the power correction factor can be quite significant. Sometimes with just adding a capacitor in front of a coil does some very interesting things. Like I said, the fan wanted to come off the desk there, and I didn't do anything more to the power, right? You know, why doesn't it work like that direct? That's when it's, but hey, all some little extras they don't even do, which would help us save a few dollars, right? What's adding, calculating the mains and adding that power correction factor capacitor behind the fan just because you know it's going to be a fan if you can save 50% of the energy and be more efficient. There's a lot of it too that our tech doesn't do that they could do to make it better with existing circuits that we already have that they won't. You see, and that it's infuriating, really, Two capacitors, and I transferred a regular motor into a much more efficient device that actually blows harder with the capacitor. You get stronger power for less usage because it's not all going to losses no more. There's been a power correction factor. So you're more efficient, so the fan runs better. It just makes sense. So I'm trying to read the question here, the back EMF. Well, back EMF, inductive kickback, a lot of people use their own terms, but essentially what you're getting at is capturing the spike. And area is dependent on tuning diameter. So yes, it's all, there is a mathematical formula to it all. Obviously, I don't have it off my mind, but that all has to be calculated. Yeah, well, it's a power correction basically. The way I see it is it matches the load to the input because if you've got a coil here and you add a capacitor, you had an LC circuit, so at resonance, it's the equivalent. It's not superconductivity, but it's the equivalent to getting a higher conductivity at resonance, which means again transfer of power becomes more efficient. So you're still ending you're using the same amount of power or actually less, but what happens is you get more efficient usage of that power. So what happens is it seems that there's a greater output because the motor is stronger, there's more wind blow, but it's all in tricks of efficiencies. But that could be deceptive for some people. Some people could jump to a conclusion and say, wow, I've just added this capacitor and my current dropped on my input, therefore I've got a gain here, I've got over unity. It's not necessarily over unity, it's just a more efficient, which is very good, I mean, there's nothing wrong in tuning your load to your input, really. Yes, the distance changes the symmetry. At high frequency, it really matters because it's also a frequency tuning, but typically speaking, it's an electrical effect as well, where the electrical impulse goes through the wire and reaches the other end. Basically, a speed of light thing. But even at the speed of light, there is going to be a variance if one conductor is longer than the other that has to control two MOSFETs at the same time on each side of the coil. So if they're supposed to be symmetrically configured where they turn on and off at the same time like you want them, one is going to lag against the other if one conductor is even slightly. And with this kind of switching, even 2 inches will make a difference electrically. It seems like nothing to us because it's the speed of light, but these transients we're looking after, especially supported with the new Maxwell interactions that I found with the deep dive in Maxwell, and it supports that these events are very, very sharp. So, yeah. Yes, exactly. Power correction. And we don't do that very often, I've noticed, in a lot of circuits, especially analog devices like light bulbs and motors and fans. I get it with computers, it's a little bit different in integrated circuits. You'd have to change the whole design of everything from A to Z. But when we're talking primitive devices like a power tool, a drill, stuff that really takes power, you could really offer an additional stage, which is power correction, and really save just doing that for somebody who needs to use these power tools all day long for a business in their garage or something. As long as it's fairly analog, you can do the power correction trick. Yes, the fluorescent light kind of does act like an antenna. What is the theory behind it is it converts the scalar wave from the system back to EM energy, and the multiple coils and capacitive layers interact, and through the AV plugs give you back pure potential out of it. That's the theory behind it anyways. So you could optionally probably use a plasma globe as well. Plasma does that. It's known to convert X-rays, scalar waves, gamma rays, that sort of thing back to EM and the other way around. So it's a very interesting interaction. So I just assumed it was just an idea I had to take advantage of the plasma-like properties of the lamp. If there were indeed a lot of scalar interactions, this would help in converting it back into a form of more compatible radiant energy that could be captured with traditional LC circuits. In my case, the layers all around the tube. And by using the AV plugs, it's a way of getting the pure potential on one wire of each device, so you're not closing the loop on each one of them, so they remain all open circuits. So their reactive properties, what we call the VAR power, can remain untouched because you're not closing the loop. And that's thanks to the AV plugs, which is the two diodes on one wire, cathode anode twisted together, essentially feeding on one wire, the other one is left open, then you have your negative and positive, and that's your pure potential, DC. Any kind of diodes, you want to go for the ones that have the lowest forward voltage. They have some that are 0.2. I've even used transistors. Transistors are very, very good as diodes. You can short the base with the collector, then you end up with a diode, and very, very doesn't require, sometimes just 0.1 of a volt is enough to break through it, and relative to regular diodes. So I've used transistors as diodes for that, because that RF energy, they're more sensitive, what I'm getting at. So you can essentially build a crystal radio with transistors instead of diodes, and it'll work the same way. But not a lot of people do that. Yeah, it does make it susceptible to the environment, of course, and that's a problem with a lot of people experimenting with this, getting different results. If you're going to use the environment constructively, you have to figure that out versus using it destructively, because it could work either for you or against you, right? So some people, Bedini even suggesting, using ground loops with two different points through your circuits, so you could take advantage of the ground potential as well, but that's going to vary, right? So depending on what your conditions are, you may even have to shield it if it's destructive interference from like maybe a UHF television station or something that's screwing around with the switching, and you can't get away from it. So yes, it works both ways, right? It could be a benefit if you want to turn it into one and work around it, or it could be a negative. Hello, everyone. I just noticed some people have just walked in here. So yeah, I don't want to repeat myself, unfortunately, because it gets really boring. But it's all here what I've been talking about, and I'm going to save this because I think it's a very it turned out to be a very interesting and educational discussion. So I am definitely going to save an offline version of this because I'm pretty well wrapping it up here. I have to say what I have to say. I wanted to show a little bit more emphasis on power correction because we don't talk about that enough, in my opinion, which is basically an extension of our reactive power supplies. Also very good for electromagnetics and that sort of thing if you're into electromagnets. Power correction could greatly help in reducing the heat you would normally get from an electromagnet and get the same strength out of it. So yeah, so much to talk about. It seems like there's never an ending to it, right? Once you get into it. So again, hello to everyone, and thank you for all for tuning in here. And I guess I'm going to wrap it up because I've said pretty well what I wanted to talk about today. And I'd like to thank everyone for watching and interacting as usual. And again, always available as much as I can to answer questions. So if there's something I couldn't get to, just write it into the video comment and I'll try and get to it. So with that said, folks, again, have yourselves all a great day and thank you for your time today.